So, greetings to everyone. Myself, Abdul Karim Shah, and I basically developed PIPSA PK on the PIPSA Earth, and this is my undergraduate thesis work, and whose title name is Net Zero in the Electricity Sector by 2050. PIPSA PK study on Pakistan's energy transition. Without delaying, let's go deep now into. This is the brief introduction. Myself, Abdul Karim Shah, and I completed my bachelor's in the start of this year at Mehran University, Jamshoro, and this thesis supervised by Dr. Fahimullah Sheikh. And before going into the PIPSA PK, let's little bit touch about the country background. Basically, Pakistan is located in South Asia and surrounded by mainly by four countries: China, India, and Afghanistan, and Iran in southern side. Arabian Sea. And one of the biggest thing is that Pakistan is the fifth largest country in this world, and 60% populations are young people are living there. And one of the biggest uh, the thing for the Pakistan, that's the in every year we are impacted by climate change. According to the German Watch report, the Pakistan is the eighth most vulnerable country and only limiting less than 1% of global gas emissions. Apart from this, the total installed capacity of Pakistan is 46 gigawatt and mainly depend on the fossil fuels, and 62% generation mix comes from the fossil fuels or thermal based power generation. And the problem statement of my thesis was Pakistan faces high electricity cost due to the bad governance, poor decision making, and the lack of transparency. And this is can be easily shown by the timeline framework. Basically, in Pakistan's power sector planning, there are mainly two major components. One is the generation planning, second one is the transmission planning. The major factor which rise the electricity prices, that is the gap between the generation planning in from 2005 to 2019. Uh, uh, the regulator assigned assignment to the system operator to design, to study or simulate the power sector generation planning in 2005, but due to the different circumstances, this delay majorly lead the high electricity cost. Apart from this, there is no also transmission planning parallelly developed by the system operator until the 2024. And this lead major gap between the our installed capacity is 46 gigawatt, but our summer peak demand is approximately around 30 gigawatt in summer. And when we go look at the winter, its demand decreases up to the 10 gigawatt. And in 2024, there is a uh, the IGSEP, Inductor Generation Capacity Expansion Plan, simulated by the system operator, but in other simultaneously study conducted by the Renewable First and Pride, they analyzed that the 5.7 billion can be saved in BU case. And this study is done by the Pelixo, and in the as we know that the Plexo is more expensive and black box tool, and every stakeholder or the every related will not support this financial assets. So open source energy modeling is the better way to tackle to support the government regarding the transparency. And this bad governance or lack of transparency, Pakistan's circular debt is around 8.57 billion, and it is increased day by day. And this circular debt further increased the high electricity hikes 14 times from July 2020 to 2024. The my research objective was first study to validate the PIPSA PK model with the national data, and second was that to develop the IG-safe scenario from the time horizon 2024 to 2034 to check the capability of PIPSA Earth or the PIPSA Pakistan. And third one, to develop a long net zero electricity sector system plan for Pakistan using PIPSA PK, considering the eligible renewable potential. The methodology, basically PIPSA PK built on the PIPSA Earth structure. In PIPSA Earth structure, basically PIPSA Earth firstly collect the different types of data, GIS based and non-GIS based data. Then it further clean the open street map data in cleaning process, and also it modifies some data, and then this data will integrate it into the PIPSA framework, and then this framework optimize the using different solvers to give outputs or the optimization results. And what we done in this process, majorly we done three steps. Firstly, we will collect the power sector data from the different reports like state of industry report or the different national reports, and then these data we mapped on the OpenStreetMap, and also convert into the CSV file or the GeoJSON files. And secondly, we will also consider the policies, the what are the different policies or the non economical parameter like discount rate, CO2 emission factors. And further, then we will design a constraint like capacity factor constraint, because our capacity is 46 gigawatt and our demand around 30 gigawatt. So if we need we design capacity factor, also consider other factors. And this the PIPSA PK model is comes. Apart from this, the results section, firstly, we will validate the power sector infrastructure. This is the transmission line and grids, HV lines. This is the official map of the power sector of Pakistan, and this is the generated by the PIPSA PK model or the OSM based. In this model, the red line shows the 220 kV lines, and the green shows the 500 kV lines, and the purple show the 60 kV lines, and the cross show the station. So let's verify this data. This is the statistical data from PIPSA PK and the system operator. When we check the in terms of the accuracy, the PIPSA PK length in terms of 220 kV lines length is 4.02% less than to the NTDC. This is the short difference between the two data frames. And in terms of 500 kV data, we check the NGC length or the NTDC length is 4.09% higher than the PIPSA PK. And we will look into the HVDC line. There is a 15.72 higher difference between the system operator data and the OSM based. This 15.72% higher is due to the two electrodes on each near to the converter station. By after the cleaning process, these 80 kilometers are removed, and the difference between the actual data is less. This is the all about the transmission grids. And in terms of the power plants, there are 42 gigawatt dependable capacity is inputted into the model. There are also different parameters, their geographical locations, their capacity, their install commission date, and other factors which are similar to power plant matching tool. After this, these both data inputted in the PIPSA, and this the PIPSA created are the non-optimized or the base network. Here we can also verify that in northern side of Pakistan there is a huge hydro installed capacity, and the middle there is also open cycle based generator or the combined cycle turbines which are basically on gases. In the southern we have installed capacity of wind. And apart from the results, in terms of the validation demand, basically Pakistan's power sector, it mainly divide into three parts. One is the northern side, second one the center, and third one is the south. And here we can also check that the majorly demand is distributed across the uh, center region, and this is also validated by the system operator of the national report that the 63.7% is manually data is in the center region, and in the PIPSA-PK model is 51.45%. And this is the majorly demand is due to the Pakistan's GDP. 60% comes from this northern region, and 50 above between 50 to 60% the population lies here in the north center. Apart from this, the Balochistan is the majorly. Here we can see that there is a huge area, but there is the little bit demand. And when we check this, there the Pakistan's 6.3 population lived here, so also verify that the data is more accurate. And we will check the differences. There is a uh, huge difference, minus 12.3 difference. This difference is due to the overlapping of different regions, because parts of Pakistan uh, uh, distribute the grid station on the basis of the Varnoy cells, but in the actual, it is on the basis of the different regions, different districts. So we should also consider in future this type of data. Apart from the validation of potential of renewables, according to the PIPSA-PK model, the solar potential is spread across the entire country, and this validation is also done by the World Bank. Yes, we confirm that Pakistan has a high solar potential, which is in terms of GHI is 5.6 kilowatt hour per meter square per data, and especially in Balochistan, this is the, and also there is also a huge area available. In terms of the wind potential, PIPSA-PK shows that in southern and western region there is a huge wind potential, and a little bit in northern. This is study also confirmed by the global wind atlas that Pakistan has a great wind potential in south and west of the country. Apart from the validation, we will also in terms of dispatch, there is this graph mainly shows the three parameters, three different type of data. One is the actual data which is we consumed in 2024, and second one is the projected by the system operator, and third one is the data PIPSA model or the PIPSA-PK model. We analyzed in summer, autumn, and winter, spring. We should notice that the important call data is our dispatch in PIPSA-PK, because the when we saw here that the projection in the by the system operator and the PIPSA-PK model is the match, but the actual consumption is low because the our demand is low, and second one is it is imported coal based, and due to the uh, different other factors. And carbon combined cycle based generator is also under this page, because we have these power plants is in the middle of the country, and middle of the country, and also demand is in the middle of country, and there's a big difference between the transmission line capacity contingency. So this is uh, and this mismatch also due to the model focus on cost optimization, while in real we also consider the different factors like fuel, logistic, maintenance, schedule, must run, and the line transmission line contingency. In hydro is misrepresented our dispatch in winter spring due to, because we in PIPSA we have PIPSA Earth, we have not accurate availability of water flow. That's why this leads. Apart from the validation, we have also studied two basic scenario. One is the IG safe scenario, and second one is the net zero scenario. In the capacity expansion plan from 2024 to 2034, we inputted the different committed power plants into this model, and we also analyzed that there is no major capacity expansion due to the LRD committed capacity plants. In 2024, there is 42 gigawatt optimized capacity. In the 2034, it reached around the 54 gigawatt capacity. And apart from this, the total capacity optimized from 2024 to 2034, 2013 megawatt optimized from solar, which is also near to the system operator study from same horizon. That is the 2107 megawatt, and 87 megawatt from the hydro and from solar. So in this study, we also not consider the potential of hydro. Apart from the major transmission line capacity is not required due to the increase in basically in 2024, the annual line utilization factor is 32%, and in 2034 it reaches around the 48%. We also that the PIPSA-PK model utilize the more capacity of transmission line. Here's a little bit capacity expanded in 2024. This gray line also arrow shows, and gray line shows that there's little bit expansion need of transmission line to 2024 and in this 2034. Apart from this, the IGSAF scenario, in the net zero, we analyze that optimized, we need a lot of large solar farms strongly near to the Balochistan region, and the majorly generation mix from 61% from solar, and also from the battery capacity is 14%. Uh, let's check this. Is it good optimization or the PIPSA-PK led miscorrection? So basically, as we know that Pakistan is the one of the best solar output country. In this Pakistan, 300 days a year, solar is shine here and above the global average. Apart from this, this is also a study conducted by the World Bank. Only 0.07% of land is required for the Pakistan to fill its energy demand using solar energy. From the 2019 to 2024, Pakistan also imported 22.6 gigawatt from solar PV, which also support our study that the Pakistan has a great solar potential, and which is the least optimization. Apart from the transmission expansion, there is a huge capacity expanded from northern to the center to carry from this power flow from to the center.
Sorry
This is the
to
capacity
interrupt,
expansion.
Abdul. Sorry to interrupt.
Yeah.
Maybe if you can wrap up the presentation, because otherwise we won't have time for questions. So if you can maybe jump to the conclusion. So
Okay, I will try.
Yeah, thank you.
In terms of the operation results, in the IG SAFE, the RE share is 35% to the 55%, and the majorly the conventional power plants provide the flexibility, and the nuclear hydro plays a base role. And the net zero, we will check the majorly demand is fully fulfilled by the solar PVs and the batteries. During the day, battery is charged from, we can also see from here, and nighttime it discharge and provide the flexibility. And except summer, there is also a curtailment issue in this section. We also consider in future that how we will optimize this potential. In terms of CO2 emissions, basically CO2 emissions from 2024 2034, there is this data also validated. This also related with the Benchmark are the study conducted by the system operator. Emissions decreases from 54.21 to the 44 MTU2. In terms of economic parameters, the annualized system cost in IGCEP scenario decreased by 28.2%. In terms of energy cost, it is also decreased from 23.6 per because in the energy mix from increases from renewable share increases, and the generation cost reduced by 28%. And this is also in system according to the system operator study, it is also decreased by 45%. In terms of net zero scenario, it is approximately increased by 165% because there's also need of huge capital cost to build such a huge solar, and the generation cost also reduced by 92%. So this is the conclusion that the PIPSA-PK model has a capability to provide the IGCEP scenario like, and Pakistan has a great potential to develop future scenarios and renewable share. And net zero path require 170 gigawatt capacity by 2050. And thank you for everyone, and especially I am thank you for the David and Katya to supporting for me to this study. So this is from my side. If you have any
Th-
question.
Thank you, Abdul.
Sorry,
Thank
sorry
you.
for sorry for the delay.
No, no problem, no problem at all. Thank you again for the insightful presentation. We have many questions for you, but maybe just not just to avoid delaying too much with the program. I will ask you if you can go through them and maybe answer them in the chat so that all the people who ask
Just mute.
questions can have them
Yeah,
answered. Yeah,
yeah,
maybe we'll go with the first one here. What are the data customizations done for PyPSA Pakistan? Was custom data used for demand, or was the default
yeah,
SSP to 2.6 demand
yeah.
projections
In
used?
PIPSA-PK in PIPSA-PK we used SSP 2.2.6 demand projection. The weather data for the IGCEP scenario is 2030, and for the 2050 we use 2050. To trade neighboring countries, and
Maybe Abdul,
in future,
sorry, Abdul, since we have many questions for you,
yeah,
I will ask Zio to collect them and send them to you. And if you wish, you can answer them in the chat,
yeah, I will.
so
Yeah,
that you can be as much insightful as you want with them. Also, then before
okay,
the lunch break, we can have like even a networking session during the break. So if you want to stay with people
okay.
who ask us questions, you can go through them. Thank you once again, Abdul.
Thank you.